In this video, I'll be covering question 1, part A from the 2023 AP Calculus AB free response calculator required portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those answers, please check out my other videos. All right, so looking at part A right now, it's telling us using correct units, interpret the meaning of this definite integral here. The integral from 60 to 135 of f of t dt in the context of this problem. Then the second part of this wants us to use a right-hand Riemann sum with these subintervals to approximate the value of that integral. So let's go ahead and take care of the first piece, which is what does this thing mean? So we're looking right now at the integral from 60 to 135. So these are the t values right here, right? So t is in seconds, so this is 60 seconds down here, and then this would be 135 seconds up top. And an integral is always an accumulation tool, and it's accumulating whatever is going on inside that integral. So what I like to do on these, some of these are easier to find out than others. Like when it's gallons per second, miles per hour, things we're relatively familiar with. These things aren't too bad, but sometimes the units get a little funky. So I just sort of do it like a unit conversion game. The f of t units would be in gallons per second. So this would be gallons per second. And then you're multiplying that by the dt. So the t units here are in seconds. And so what you're getting out now, you'll notice that the seconds cancel with seconds, and so you're getting out the total gallons. And it's the total gallons pumped in or added to, pumped into the gas tank. So they're saying a customer at a gas station is pumping gasoline into the tank. So it's the total gallons pumped into the gas tank between time, whatever that lower limit is, 60 seconds, and 135 seconds. So that's the first part of this. What does it mean? It's the total amount of gallons pumped into the gas tank between the time 60 seconds and 135 seconds. Now the second part of this wants us to go on and do a Riemann sum, a right-hand Riemann sum. Whenever I'm doing Riemann sums off of a table, I like to pull that data off of the table and onto a number line. I just find that it's easier to read that information off of a number line, and oftentimes they will switch up the size of your intervals, so it's also easier to kind of see when that's happening. So label out your intervals based upon what they're giving you here. So this would be from 60 to 90, then from 90 to 120, and then from 120 to 135. And then what I do after I label out what are essentially the x values is I come back in and put the y values that go with them. So from there, 60 goes with 0.1, 90 goes with 0.15, 120 goes with 0.1, and then 135 goes with 0.05. And then what I do from there is I come back and I sort of label the gaps. That'll be area 1, area 2, and area 3. And then I just call the rest of this sort of my assembly line process. I go area 1 equals, area 2 equals, area 3 equals. And then remember that what we're doing here is the area of a rectangle. And the area of a rectangle formula is base times height. The base is always your delta x, the gap between your x values. So when I look at these, I'd look and I would say, okay, my delta x, my base on that between 60 and 90 would be 30. My gap between 90 and 120 would again be 30. And then my gap down here, oh crazy, not 30. Don't fall for that trap. This one is 15. So I come in now and I put my bases for each of my areas. So this will be 30, this will be 30, and then this one will be 15. And then I'm going to multiply those by the heights. Well, the heights come from the y value off of the interval. This interval that we were doing here, these are going to be right-hand sums, so we want the right endpoint off of every interval. So looking at A1, you've got two choices. You have a left endpoint and a right endpoint. We want the right endpoint, so we'd multiply that by 0.15. On A2, you've got a left endpoint, you've got a right endpoint. You want the right endpoint, so you'd multiply that by 0.1. And then on A3, left endpoint, right endpoint, the right endpoint is 0.05. Once you have those set up, now you go ahead and just multiply those things together. You might be able to do those in your head, but you're on a calculator required section, so you might as well take advantage of it. So 3 times 0.15 gets us 4.5. Then we get 30 times 0.1 is going to get us 3. And then 15 times 0.05 is going to get us 0.75. Then what we're going to do is you're going to add all of those up. So we add all of those up, and this is going to give us our approximation for the integral from 135 of f of t dt will be approximately, and then we just add these all up. So again, you could do this in your calculator. I recommend it. Test brain. Nothing would upset you more than missing something because you just didn't add the numbers right because your test brain didn't do it right. So then this would be 8.25. Remember, these are total gallons here, so the unit on this would be gallons. So this question would have been worth 3 points altogether. We would have gotten 1 point out for our knowing what it all meant. You would have gotten 1 point out for putting together your Riemann sum pieces, and you would have got 1 final point for putting together that final answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.